These are the notes for section 6.5. In this section, you needed some basic definitions of polygons. So that's where we're going to start. So a polygon is a closed figure with 3 or more sides. Closed meaning I can color it on the inside and there is an inside to color. Quadrilateral is a special kind of polygon. It's a polygon with 4 sides. So you can see up here that these polygons, these examples, had 1, 2, 3, 4, 5 sides. This one had 4 sides. They can have 10 sides. They can have 100 sides. Quadrilateral is when we limit them to only 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. Now, you'll notice that these polygons and quadrilaterals here, some of them look familiar, and some of them look sort of not like what you would expect a polygon to look like. So there are 2 types up here. There are the convex, where the polygon has no diagonals on the outside. So this is a convex polygon, and this is a convex quadrilateral. And then you have the concave, where at least one diagonal is outside the polygon. So this is a concave, caved in. There's a side that's caved in. And this one is also a concave. Now there's a word in both of these definitions of the convex and concave that we need to talk about, which is this idea of diagonal. So a diagonal is any line segment that connects non-consecutive vertices of a polygon. So we'll look at this example here and then we'll come back up to see why it is that these 2 polygons are concave and these 2 are convex. So the diagonals are line segments that connect vertices. So we have a vertice here, 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 and here. So they connect vertices, but they can't be consecutive, meaning that this point to this point is not a diagonal. It's right next to this point. However, to go from here to this point, that is a diagonal. And from here to that point, that is a diagonal. Now from here to here, again, that's not a diagonal. So basically, the thing to remember is that the sides can't be diagonals. Now, if I continue to draw all the diagonals here, I can get a pretty design. So we'll do that, just to kind of see how this is going to look when we're all done. And you'll see here I get this kind of wonky looking star, but it's kind of an interesting thing. So if I go back and look up here at these polygons, the concave ones, a diagonal that I draw is outside the polygon. Again, outside the polygon, where the diagonals for the convex are all going to be inside. Now there are some inside diagonals in these polygons. However, all I need is one to be on the outside for it to be concave, caved in. We have 2 other definitions in this section that we want to cover. One of them is midpoint. Midpoint is the halfway point of a line segment. So in this case, we don't yet have a way to find the exact midpoint. And even when we have a way to find the midpoint, it's never going to be exact. Can't actually do that since we're human beings. So what we do when we have a midpoint is we say, let's pick that and we'll call it B. And really what we want to do is we want to communicate to everyone else who ever looks at this picture that that B is the midpoint. And the way we do that is to put 2 little lines, 1 on each side. These lines indicate that the length from A to B is the same as from B to X. So the length of AB is the same as the length bx. And since they're line segments, we'll put that lovely symbol on the top. Our last definition here in this section is about regular polygons. Regular polygons are special because they have all the sides the same length and all the angles the same measure. So just like up here in the midpoint where we said this was the symbol to say the same length, we're going to use that exact same notation on our figures down here. Now, the notation to say that two angles, or more than angles that are the same measure, is to, put these little arc marks. Just a little note here. I know that my pentagon over here doesn't look regular. And so, in geometry, we can't ever draw things to be perfectly regular. So it's the marks that indicate that they are regular, or if you're told that they are regular. Now, the regular triangle has a special name. It's called equilateral. And the regular quadrilateral has a special name. It's called a square. Every other regular figure after four sides doesn't have a particular name. You would just say that this is a regular pentagon.